Assalamu alaikum. So today our topic is SR flip-flop or the sequential logic gates. First, let's understand what is sequential logic gate. When we take logic gates, we have two types of logic gates. First, combinational, and second, sequential. So the combinational logic gate, now let's say this is a combinational logic gate. This will take inputs and it will give you output. It depends only on the input that you provided now. The output depends only on the input that you just provided. It doesn't have any memory element. Then when we take the sequential logic gate, it has two components. If you take the sequential logic gate, it has two components. That is, it has a combinational logic gate. It has a combinational logic gate. In addition to it, it has a memory element. It has a memory element. So here, both of them together, combination logic gate and memory element, both of them together, we call it as the sequential. So here, when you provide an input, you will receive an output, and the output also goes to the memory element. And next time, the data from this element is also considered before giving an output. So here, in combinational logic gate, the output only depends on the input. But in case of a sequential logic gate, the output will depend on the input as well as this memory element. The simplest sequential logic gate we can construct is the flip-flop. So in flip-flop, there are a few types of flip-flop, and the simplest memory element or the simplest flip-flop we can produce is consist of two NOT gates. Consist of two NOT gates. Okay, so here, let's say this is our input, and here we get our output. Now I'll take Q and Q dash. You will understand the reason why. Now, let's say the input is 0. If the input is 0, now we have a NOT gate. Therefore, the output becomes 1. So over here it's 0. Over here it's 1. And again, if this one goes through this NOT gate, it becomes 0. So these values are stable. This 0 and this 1 is stable. I'll now, given high input, I'll make this one 1. When I make this 1, now this is 1, and this becomes 0. Again, this is 1. Therefore, when I give 1, this remains at 0. Even if I remove, now I must give a high potential, right, to make it 1. So I'll say I give plus 5 volts. when I made this plus 5 volts only, this one became 1, this one became 0, and now this is remaining. If I remove this voltage, still it will remain as 1 and 0. So it is clear that this setup can store data, or it's a memory. Because it's storing data, we call it as a memory. So here, the inputs, if it's 0, if Q is 0, then Q bar is 1. And if this is 1, this is 0. So it can store 1 and 0. And now you should have got the idea why I used Q and Q bar. Look, they are the complements of each other. And then we have a SR flip-flop, set reset flip-flop. This is just a flip-flop. Now we are going to look at SR flip-flop. SR flip-flop means set reset flip-flop. So this flip-flop is going to get two more features, set and reset feature. SR flip-flop we can construct using NAND gate and NOR gate. So first let's look how we can construct using NOR gate. So let's use two NOR gates. Let's use two NOR gates. And take the input here and take one input. Next, draw the output. Connect the output from this to the input of the other. Similarly, the output of this to the input of the other. So now we have got two buttons, right? Set, reset. Then over here we have Q and Q bar. So this is the SR flip-flop using NOR gate. Before we discuss any further, let's understand why actually we need a SR flip-flop. And then we can come back to this idea, okay? So let's think of a security system, security alarm system. So this security alarm system, this is going to work like this. Now you have a laser light falling on a certain sensor. It is falling on a certain sensor. As far as it is falling on this sensor, as far as this laser is falling on this sensor, the alarm has to be off. The alarm is off. Alarm is off. And if the light or this laser is obstruct, if this is obstruct by certain obstacle, then the light won't fall on the sensor. Then the alarm has to sound, or it should become on. Now we have the laser light being blocked. It is blocked. So let's see if we can construct this security system using a combinational logic gate. So let's use a NOT gate. This goes to the alarm. So in this NOT gate, if light is falling, now we have the sensor. This is the sensor. So if light is falling on this, let's take it as 1. If it is obstructed, then let's take it as 0. So when light is falling on it, it's 1. Therefore, this is 0, then the alarm is off. And then we have the obstacle. Then this becomes 0, this is 1, the alarm is on. It looks like as if it works fine. But let's see, is it actually working fine? So again, I'll go back to this case, So here, let's say we have an intruder. He is getting into this building without any authority. So when he blocks in this situation, the alarm is off. It's fine. And in this situation where he is just blocking the light, the alarm is on. So it's giving out an alert. And what would happen if he passes? He has just gone past that light. So the light falls on the sensor. Then the light is falling on the sensor. This is 1. This becomes 0. The alarm goes off. So using this combinational logic gate, we cannot make a security system. Just look, it should have had the memory, right? It should have had in memory that someone blocked this light. Someone did block. 1 minute. So this become a better to make this one into a better security system. It should have had in its memory that the light was once blocked. Therefore, the alarm should have continuously rung. And after checking for all the after checking the building or whatever, then only we should off it manually. Then only it will work or it is suitable for a security system. So here it's clear that we need some kind of memory. Without a memory, we cannot do this. So I hope that you understood why combinational logic gate is not suitable. Now, let's see what we actually want. I think I already told you. We actually want when light is falling, not a combination logic gate, some other logic gate, a sequential one, where it will act like this. When light is falling, it's 1 and it's 0. I mean, the alarm is 0, so it's off. When something is blocking this light, it should become 0. So alarm will go on 1. And when the light falls on the sensor again, still it has to remain at 0, which will make this one, this will go to 1 because this is the output from the sensor, right? So this will become 1, but alarm also has to be 1. It has to be on. Then I must check around, and still the light is falling on it. This is 1 because the light is falling on it. It remains 1. And I will check for any someone within this premises, if there is no one, I will off the alarm and it will go off. So the security system is reset. Again, if someone crosses, it should again become on. So here we need some sort of memory. Look, even the light is blocked, light is falling, still this is in memory that the alarm has to work. And here still the light is falling, but here I have reset it. After looking for any threats, I have reset it. Okay, so now let's say, now you have understood what is the purpose of a memory element. And now let's see how a SR flip-flop can do this job. So initially, let's say the value for set, I'll put down the truth table for SR flip-flop. Truth table. This is for SR flip-flop. SR flip-flop using NOR gates. So this is S, R, Q and Q bar. When set and reset, you are not providing any. Now here only the signal will be, here only the sensor will be connected. Okay, in between we may use a NOT gate or whatever before this set. So when set is 0, we are not resetting. Reset is also 0. Let's say the output is 0, Q is 0 and Q bar is 1. If this is 0, this has to be 1, right? Let's say we made this circuit this way. Now what I'm going to do is, this is also possible. Set is 0, reset is 0, Q is 1 and Q bar is 0. This is also possible. Now how does this possible? Because this depends on the previous operation. Depends on previous operation. You will understand in a while how this one happens. Okay, and then we have set and reset. When set is 1 and reset is 0, Q will become 1 and this will remain 0. When I reset, the opposite will happen. Q will become 0 and Q bar will become 1. We don't keep both of them at high values. It is avoided. This is the truth table for SR flip-flop, but sometimes you might have not got how we filled it. I will explain it now. So here I have just shown what are the possible values. When set and reset, both of them are 0, Q could be 0, Q bar could be 1, or Q could be 1 and this could be 0. So both of them are possible because they depend on the previous operation. That is why we call them as a memory element. But whenever we set, Q will become 1. Whenever we reset, Q will become 0. Okay, so that is the idea you have to get from this truth table. I'll repeat. Here, look, when both of them are 0, when both of them are 0, you could get q is equal 0, q bar equal 1, or q is equal 1 and q bar is equal 0. Look, both the values are possible because they depend on what happened previously. That is why we call it as a memory element. But when we reset, always q becomes 1. When we reset, q becomes 0. And we avoid setting both of them to higher voltage. So next, let's understand. For now, we have only filled the truth table. Next, let's understand how this actually works. So again, I will draw a truth table, which is the common order we use to fill. Initially, I'll provide a value for set. That means reset is 0. I'll get a copy of that. So set is 1, reset is 0. Let's look what will happen. Q is 1, Q is 1, and Q by 0. So these are the initial values, okay? We didn't do anything yet. Sorry. When we set, Q becomes 1. I already discussed. When we set, Q becomes 1, okay? Now, I'll remove the high voltage I provided for set. Therefore, it goes to 0. And reset also goes to 0. Sorry, it remains at 0. Let's see what will happen. Now, this is 0. This is 0. If this is 1, both of them are the same. This input is 1. 0 or 1. There is 1. And when it passes this NOT gate, it becomes 0. Already we have 0. Now, here, this is 0. Because this is 0, this is also 0. 0 or 0, that is again 0 when it is passing the OR gate. And when it passes the NOT gate, it becomes 1, which is already 1. Again, go through the cycle. This is 1. This is 0. So everything is stable. Just try by yourself, okay? Then you will understand what I am trying to tell. So look, even though I changed the value of set to 0, Q remains 1, Q bar remains 0. None of them changed. None of them changed. Now let's see what would happen. When I reset it. So when I reset, set is 0. So this is 0, this is 1. So Q bar is 0. That means this is 0. 0 or 1, that is 1. When it passes the NOT gate, it becomes 0. 0 or 1, that is 1. When it passes the NOT gate, it becomes 0. So Q changes to 0. If this is 0, now this input is 0. 0 or 0, that is 0. When it passes this NOT gate, this becomes 1. Therefore, Q bar changes to 1. And here, the input, this changes to 1. Now, again, let's go once again. 1 or 1, that is 1. When it passes the NOT gate, it is 0. Now it's stable. When it went through one loop, it became stable. So the value of q is 0, the value of q bar is 1. Now what I'm going to do is I'm going to remove, I'll again rewrite these values. Okay, after it's changed, now q bar is 1, q is 0. If this is 1, this is also 1. If this is 0, this is also 0. Now what we are going to do is we are going to remove remove reset. So this will become 0. Now let's say this is 0. This was 1. After removing, it's 0. 1 or 0, that is 1. When it passes the NOT gate, it becomes 0. So this same value remains. 0, 1. Look, here when I set and remove the high voltage, the memory remains. When I reset, the memory changes. And when I remove the reset, still it remains. So over here and over here, it's acting as a memory. I hope you all understood the idea of flip-flop. So here you don't need to remember, you don't need to remember how we got these values. To understand only, I explain what is going through. But to remember, you don't need to remember these values. What you have to remember is this truth table. So here we have 1 and 1 avoided. Then you can write the truth table in both the orders. You can write in this order or this order. But I think this order is better. This order is better because you will clearly understand what's going on. From 1 to 0, what's happening from here, what's happening. So this table has to be clear. And we can construct the SR flip-flop using NAND gate also. So there you will need 4 NAND gates. The same idea once again, using NAND gate. First, let's draw the NAND gates. Take one input and take the output. Connect the output of this to the input of the other. And here we will need a NOT gate. So we can construct a NOT gate using NAND gate, right? By taking only one input. So now it's a NOT gate. So this is set, reset, Q, and Q bar. The same principle. So here I have explained and I will upload the note separately. So just go through the note and this video so you'll understand. Okay. Assalamu alaikum.